Welcome. In this video, I will explain how to take movie reviews for both Barbie and Oppenheimer and how to put that into a table or a data frame where we can use tools for data manipulation that we already know from the Tidyverse. The reference for this video will be the excellent book Text Mining with R. Website for this book that you can access freely is tidytextmining.com. I really recommend it. It's a really beautiful book, really amazing. The link is also in the video description. So the source for this video will be reviews from the web, such as this one, that I've copied and pasted into Notepad one by one, organized into individual files, one per review. We will proceed to import this unstructured text and convert it to a table. To do that, I will use different tools. I will use dplyr for data manipulation, put for iteration to repeat the reading and cleaning step many times, tidytext, that's a specific package for text analysis. So here I will start by listing files. So I will create two vectors. Each of these vectors contains the different reviews. One vector contains Barbie reviews and the other one contains Oppenheimer reviews. So now if we use the mapdf function, I can proceed to iterate, but before iterating, let me show you the steps for one file. So here if we set x equals fimp1, that means the first review for Barbie in this case, we can detail the steps of it. So first we create a table indicating the review and the text, and this here contains each line of the review. Then with the nest tokens function, we create a new column called word, where we divide each line of the text column into individual words, so we can show the step up to this point. And here we have the BBC review for Barbie with all the lines split into individual words. It's one word per line. And finally, we will proceed to remove stop words, which are words that are not informative because those are too common, such as on, at, and this is the list of stop words. So if we run that for the first review for Barbie, we end up with a table, and then we want to repeat that for each review. So then for the iteration, I've created a vector with the two reviews, both Barbie and Oppenheimer. So now what I will do is to run this, and this will repeat the same step 1, 2, 3, 4, 12 times in this case, and I will end up with one single table. Now I will proceed with the analysis, because what I've done now is just structuring this. The Barbieheimer table contains a list of words per review, so I can count words. So this counts is telling me the word Barbie was mentioned 197 times across all reviews, and Oppenheimer was mentioned 113 times. But then I can refine my count a little bit, and then I can proceed to count considering the source. And this count is really similar to group by and summarize from dplyr. So now if I conduct that operation, that's telling me, for example, that in the New York Post review of Barbie, the word Barbie was mentioned 42 times, but in the Times review, the word Barbie was repeated 41 times. We can see that movie, for example, here is not informative. We are talking about cinema. Film is also not informative. So these two words become stop words in this context. But for example, Barbie and Oppenheimer are informative words. So then it's justified to use TF-IDF. So if we go to the text mining website, we can search for the TF-IDF. And here we have a really nice explanation for the TF-IDF. Okay, so now back to RStudio. So the TF-IDF is a good metric for relevance. So what we do now, we are going to create a table called Barbieheimer TF-IDF, and I will conduct a count same as before to obtain the n column for the counts of words, to count the frequencies in absolute terms, like 1 repetition, 2 repetitions, 3 repetitions, etc. And then I will use the bind TF-IDF function, where I indicate the source, and if I run that, then I can get my table with the TF TF-IDF. But in addition to that, this also provided the term frequency. This is a relative measure, not an absolute count. The TF is a proportion, and the IDF is the inverse document frequency in a logarithm. That's really well explained in the book I just mentioned. We can check if the TF-IDF is the multiplication of the TF, and this result that already has the log applied, the logarithm. So we can verify here if 0.213 times 2.15 is equal to 0.458. And that's it, and it's the same. I would like to record a second video. Please tell me in the comments if you would like me to create some plots for TF-IDF, or if you would like me to explore what would happen if I didn't remove the stop words.